So this is a long anticipated and frankly a little bit overdue day, and it's this. I get to interview the world's finest son-in-law. You already met him on the spec house, right? Ben put in the low voltage for Nate and I on that spec house project. And he has been doing the electrical work, both high voltage and low voltage, in his own shop slash office slash garage project we've been working on now for a year. Now, he's been patient, and I've been patient. We're still speaking to each other, which is not a small accomplishment. And I was frankly thankful that it took Ben 5 months to do the electrical work in here. I'm going to turn the mic over to him now, and he's going to describe to you his learning curve, how his professional training, and he is now the electrical engineering and computer science program director, online program director for Oregon State. He works remote. He also drives to Corvallis and teaches in person. He's a busy guy, and filling in the cracks in that schedule, he's taken care of everything electrical. He's turned out a nice product at last, and it gave me a nice break when frankly I really needed it. So Ben, talk to the people about what you brought here.
Great, awesome. Well, thanks again. Couldn't have done this without you. Having this dream turn into reality has been a real thrill, and it's been something we've been, it's why we bought the property. We didn't know that we were gonna have you do it, but the dream from the inception of walking through it involved some sort of thing here, some sort of building.
So he's got a lot to say, he's had a lot to learn, I've had a lot to enjoy from the sidelines, and I'm going to turn this over to Ben. He's going to describe how he turned in what ordinarily would be thought of as a shop slash office slash garage into an office slash laboratory.
Simplicity and overkill. That was the objective. So how did we get there? The first thing that I did, and I think the most important thing that I did, was to reach out to a friend of Scott's and ask him to teach me the design language for what we're doing here. So I reached out to Kevin Eckerman, who is a master electrician here in the Roseburg area, and had him design some plans for what the electrical system would look like, just high voltage, just the 120 and 240 volt systems. And once that was done, then I took that design language that he had taught me through that, the elements of code that were embedded into the design that he had, and went back and added the plugs and the switches and the circuits for where I wanted them to be. So I took his design document and turned it into my own. Okay, so this was the plan that Kevin had come up with, and it was all in pencil markings. It was wonderfully drawn and rendered. And some of the key features that it had were plugs along the walls and lights in the ceiling. That was key information that I needed. I didn't know the symbology. I didn't know the way that the cables connected. Once I understood how he was expecting things to be done and how the inspectors were inspecting things to be done, I could add in the parts I wanted. So I went from the perspective of where do I want plugs first, and what kind of plugs do I want? I was looking at the standard duplex and also the quads. So we got 4 and versus 2. I also wanted to add some 240 volt receptacles and then about 1 billion low voltage outlets as well, or jacks. And we'll go into the low voltage here in a bit. So in terms of the lights and plugs, the standard symbology was followed for the quads and for the duplexes. And I colored them all in pink. You can use whatever color you want. I used pink so that I could see it at a glance. And for lights, I used the standard circle with a cross symbology in it and colored them all yellow. And then I colored my 240 volt lines in blue, or the receptacles in blue. Then I started connecting them together with colored lines so that as I put in these circuits, when I had time, I could work on a specific circuit at a time. So they're all color-coded. As I did that, I built up a little chart that told me the number of circuits that I was adding into the building. Now I know that it's overkill because there's no reason for me to have so many separate circuits along this back wall that we're here. It's unlikely that we're going to be running a grinder and a welder and a table saw and a drill press all at the same time. But if we wanted to, we could, because overkill and it's simple to use as a user because I can plug anything in anywhere and know that you've got practically the entire circuit for that one device. All right, I also added in a fan circuit for up above, garage door circuits, there's a heater in the bathroom, water heaters, all that is included. So I want to stress this was an absolute thrill to do. Not only was I trying to achieve a specific result, but I wanted it to be fun, and it was fun. And I'm kind of sad it's over. I wish there was more more electrical work that I could do. I am not an electrician, and I'm sure all of you tradesmen out there who are seeing what I'm doing, seeing the designs, even the way that I've put the boxes in, I'm sure it'll make you cringe. Certainly this is not necessarily a recommended way to meet code in whatever your jurisdiction is. But I met our code and already passed our inspections and had a blast doing it. For the lights that we put in, I decided to go with big LED panels instead of little cans. The LED panels are cheap, they're bright, I can change the temperature on them. I have lots of overhead ones for the main shop area, lots for my office, and then I added in a dimming system for it. My objective was so that when I turn on the lights, it's so insanely bright that I have to use that dimmer to bring it down to normal levels. Because sometimes when you're working with very fine tools, you're working on little tiny things, electronics, you do want that high intensity brightness. I understand the difference between work lights and overall light, but I wanted it bright. So overkill on the number of lights that are up above and the number of lumens that are above. Since I am more on the engineer side than on the electrician side, and I don't necessarily know what I'm doing, I wanted to make sure that the system was testable before we then pulled all the devices back out of the boxes and started putting insulation in to cover up all of the wiring. So a few of the things that I did. For one, I used pigtails on everything. This is just a standard light switch. This one happens to be a three-way, that's a three-way light switch. And when I put these all in, I made sure to use pigtails on all of these so that I could put the entire system in with all of the devices, test it to make sure it all works, and then just use my little Wago lever locks to disconnect it and pull it out. So it's easy for me to remove, easy for me to add back in once the drywall and is all in. So how do I know where they all go? Every single thing on the design has a label. So every box, every slot, every switch, they all have a specific label. And all of the devices that I used for testing are written. And then inside the box itself, both on the top and on the inside, there is a label that tells me what each one is. This is Foxtrot 1, this is Foxtrot 2. So let's look at the connector that I used for these. Instead of going with wire nuts, I went with a lever lock connector. These are made by Wago, and the way they work is there's a simple lever that you detach, and then it simply comes off the wire. Easy to put on, easy to do, doesn't require, frankly, a skill in wire nutting that I don't have, and it makes it much easier for me to test with. It also has a little touch point there. Once things are wired and power is running, you can use a multimeter to test to see if you actually have voltage there without needing to have it be in an unsafe condition where the wires are exposed. So I used these for all of my high voltage wiring in the shop for connecting wires together, with the exception of some of the larger 240 volt devices that needed to be wire nutted. These are only rated up to a certain size wire.
What I want to brag about is when we started this project, he was deathly afraid of heights. If he got over about 6 feet off the ground, it was unmanageable.
Couldn't do it.
Right? He couldn't do it. He couldn't do it. And I insisted, well, actually, yes, you can, and not only can you, but you have to, right? And by the time he was about 2 weeks into this project, not only could he pull himself up the side of a scaffold, but he could get onto the top and he could work up there. And frankly, I'm proud of him because it was a gut level, visceral, survival instinct thing that you had to change a mindset on.
Scott set me up with this wonderful scaffold that rolled around here, and I can't highly recommend that enough. Having something you can work on And when I'd climb up there, I could then push myself around using the ceiling to move around as I did all of the high wires.
He wouldn't consider that at first. I
Could
mentioned
not
that to
believe it.
him, and I could just see he kind of glazed over and, right, old man, right, I'm going to do that. But you did.
The first time you left me,
Yes.
you had gone and the scaffold was here, and I climbed up it, and I could not get back down.
You stuck.
I was stuck, and I sat down on that upper platform and could not get over the fear of needing to move myself, my center of gravity, out back over onto the ladder and go down the side.
That
of it.
transitional action is
Couldn't do it.
scary.
And my one of my kids came in, and I talked with him for a while, me up there, him down below. And then after about half an hour, I realized I can't stay here forever, so I had to make the jump. And after that moment, it became easier. You had to step through that fear with nobody but yourself to do it.
Okay, so can you see how that fits so beautifully into some of the themes of this channel? That sometimes, darn it, you gotta do a hard thing to keep the job moving forward. So, attaboy, Ben, attaboy, man.
Okay, so we have come upstairs now. This is my office. There's a desk on that side, and on this side it's more of a couch and maybe a TV, maybe some filing cabinets, whatever it's going to look like. This is more of an open area. But I wanted to point out where the network cabling is coming in. I have 24 different network jacks built into the building. They're all over the place. As we move into the future, everything wants an internet jack or some sort of Wi-Fi connection. 2 of these are going to Wi-Fi access points in the building, so there's plenty of super nice Wi-Fi coverage. And then the rest of them are 2 hardwired jacks, especially around my desk area, and they're certainly along every wall, all over the place. They're all put together to come in across this, these rails, these rafters, these joists, and they are all trunked together along this ridge. So I made sure to keep this upper beam, the top of this wall, the top of this crown plate, I made sure to keep that free of high voltage lines because I knew that was going to be my highway for collecting all of those low voltage lines together. So they all stream through like a river, come down into here, and then stick out the wall where the rack will mount on the other side. So it's a little strange having this rack be sticking out into space on the other side where that staircase is. The reason I put that over the staircase is that these network racks, these that are holding a bunch of different servers and computers and modems and routers and all that stuff, the reason why this is located here is that I wanted it on an inside wall, so for better temperature control, and there's always going to be air conditioning running in here. So this is a nice climate controlled space, and it's not on the outside wall, so it's protected from swings. And also having it on this inside wall here that is exposed on all these sides means there's no insulation in here, so it's really easy for me to work with. Additionally, this thing, all of these devices have fans that are running, and I didn't want them over on my side of the world next to where I work, because it's a lot of fans, so they're stuck around the corner here in their own area. So that's why this is here. Generally speaking, the goal is not to have to do too much work in here very often. The goal is to put them in there and have them work, and all of the maintenance and administration on these devices happens from my desk anyway. I do have a conduit here set up so that I can run antenna and other devices up into the attic and up into the roof, so that's the antenna for getting things through. So what I have been using are these little metal sleeves. They have 2 little prongs on the outsides, and they hammer into a hole that you drill, and then they protect it on all sides from nails. These are handy so that I don't have to put nail plates on both sides as well. Since it's protected on all sides, I just drill a hole, hammer the thing in, and now no matter where you drill in from and from what angle, it's going to be protected. So I've really enjoyed these things. These particular ones are Southwire brand. Before we wrap it up, I'd like to show you my 3 favorite tools that I picked up for doing this job. 3 tools that I did not know how to complete the job without. First of all is this one. This is a Milwaukee cable stapler, and I started with the traditional hand-powered high voltage cable stapler, and I lack the strength to be able to get that thing to work when you're up above trying to staple sideways into a joist up above your head. I couldn't get it to work, and it was frequent that the staples would not go in far enough, or only one of the legs would go in. Buying this was a bit of a splurge. It cost like $200, $250. The staples aren't exactly cheap, although they're certainly not that expensive. But what it really represents was the ability to finish the job. Without this, without being able to press up against the wood and bam, shoot a staple in and be done, I couldn't have finished. There are 1,400 staples in this building at least. I went through about 2.5 boxes of the staples, and you can see some right here. Here you can see some of the old school staples that worked. These were some of the few that survived, but the rest of them are these red Milwaukee staples that are just one touch, bam, 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 bam. This is by far the way for me, this was the only way to finish. I also wanted to point out, I labeled all of my wires. So as I was doing, not only were the boxes labeled, but the wires are all labeled with home runs and which devices they're going between. The next one is this cable stripper. So there's lots of different strippers for removing the sheathing around these wires, but I found that it was a real pain to do. This one allows you to go into either a 14-2 or a 12-2 and remove the entire sheath at once. So you can see that it closes down on either of those two and strips the whole thing off. I don't know how to have done it at the rate that I was going without this tool. And this one I've completely used up. It's all sprung, and I don't fault the tool. It got used real hard by somebody that barely knows what they're doing. So next time I do this project, I'll go out and buy a fresh one. The last tool, when this wouldn't work, was this old school stripper. It has a little hook with a knife on it that you can put on any width cable and run it down to open up that cable. So this worked on a lot of the oddball cable sizes that are around here. So these two were necessary for the cable stripping, and that stapler was necessary to attach them to the wall.
So this whole sort of phase of the construction of this little shop illustrates something that's really important for a lot of us, and that is identifying what your strengths are, identifying what your interests are, identifying what your resources are that can compensate for your weaknesses and where your strengths are, so that you can actually put in some sweat equity. And that's what Ben did here. It's sweat equity, the work that you can do on your own projects that save you from having to shell out money. Now, you know, and we've talked about this, that some portion of the money that you saved in not paying an electrician was spent on additional material in order to get exactly what you wanted.
Absolutely.
Okay? And that's a fair trade. I mean, it is entirely reasonable to save the money where you can and spend it where you need to in order to be happy with it long term, right? Have you got any reason to think you won't be happy with this electrical long term?
No, absolutely not. It was designed by an electrician originally, then my design, and then the electrician came over at other key junctures to make sure that I was doing it right. I had him come through about a month in after I'd started. Mm-hmm. He looked at the cabling that I was doing. I made sure to have at least a couple of circuits completely ready, and he checked them to make sure that I was both following code and that it was at a workmanlike manner, that it was efficient and would help us pass the inspections.
So that's really important, and it gets back to the recurring theme that the people you know in your life make your life better. So we're working down towards the end of this project. But tune in next time. You're going to get some details on insulation. That'll be followed by some details on drywall. And then we'll be casing and basing and putting some carpet upstairs, trimming out the electrical, and laying this project to rest. Kevin Eckerman, thank you for helping my boy here.
Absolutely. Thanks, Kevin.
He's worth investing in. I certainly have learned that. Thanks for watching Essential Craftsman, and keep up the good work.